Hello everyone. So this is the last interaction session that we are holding for the course on advanced robotics. My name is Soumya and I am PMRF fellow at IIT Gandhinagar. So I have been your TA constantly for this course for over 12 weeks. So it's the last day of the session and I request you, if you have any doubts, any clarifications that you need for any question, any topic, you're most welcome. Let me know if there is something. Else, one more thing, we have completed 12 weeks. So all of the lectures, so let me just put it on record also. So this sheet, which is already shared with you, just a minute. This sheet, yeah. This sheet has already been shared with you. So it contains the YouTube links of all the exercise questions that we have had. Then the presentation folder link, which takes you to all the presentation and PPTs that we had. And yeah, so both of these things will be extremely useful for you. Please go through them in case you have missed any lecture, have not attended, or want to clear doubts on specific topics. So these questions are basically tutorial questions that actually helped you in solving your assignment question. Moreover, they're like uh, if you have like missed on some concept, then also they'll help you clarify them. Plus, apart from the questions, the basic concepts have also been covered, though it was already covered in the lecture by Professor Ashish Datta. But yeah, still we had a few coverage of concepts, some revision, and some new insights that we can develop. So all of these things were there. So I kindly request you to go through any video that you want. Okay, all of them are uploaded, all the slides are there, all the codes are there. Some of the codes are uh, uploaded as .m file, the MATLAB files. Other codes are there as a part of the slide only. So you can have a look at all of them. So the syllabus that we have covered was this thing completely. And in the last class, when we were doing bipedal locomotion, we were also looking at some optimization problems. Given you have an object and then you have a multi-agent system. So here multi-agent we consider to be mobile robots, but they were not essentially the mobile robots. What we actually thought is, if we have an object and then we have 5 fingers grasping it, then all those 5 fingertips are mobile robots. Okay, that is the way we dealt with it, and then we tried to find out, okay, what is the wrench that we require so that it does not have any freedom angle to move, or what is the way of holding that will restrict its motion, and all of those things. So we were seeing them, right? The form closure, force closure, everything we have seen. And then we did this for biped robot, then we saw some optimization thing. So till now we have been doing everything on kinematics, dynamics, then control. All of these have been done very well. And then yeah, since we have done these, so I am planning to have it as an extra session where I'll be teaching. So if you're going to be a roboticist in future, or you plan or you like to tinker with the things, you might know that computer vision is something that is very important, right? So before proceeding with it, if you have any doubt or clarification, let me know. And today's session is just gonna be 1 hour session. It's not 2 hour session. So yeah, you can clarify your doubts, else I'll proceed with computer vision. Since there is no response, I think I'll proceed. If you have anything, you can share with me at the end, right? Okay. So, how can I remove this? Yeah. Okay. I hope this is on record. Let me check. Yes, it is. Okay. So let's start with the next slide. So yeah, but just I wanted to take into account the course layout and the books that we had. So I'm sure you are preparing for exams as well. keep in mind these books and references. They will be helpful. The most important of all is Robot Dynamics and Control by Spong Vidyasagar. Like, they're the best of all. Now, after that, yeah, all of these things we have done, DH parameters, even we were dealing in last few classes also, singularity, trajectory planning, control, multi-figure grasping, locomotion, then kinematics and dynamics of walk, then yeah, all of these multi-agent systems, all of these we have done, right? Uh, Now, let's move to today's topic. Okay, so my point is, uh, so in this 1 hour session, we are going to basically explore how vision enables robot to interact intelligently with the world around them. Okay, so we'll go from very basic image understanding to real-time applications like object detection, face tracking, or let's say an autonomous mobile robot is using some visual feedback. So this is a foundational topic that combines AI, robotics, and image processing. So these are all of the vital areas in today's robotics industry, right? So what we can say is, so what is computer vision actually? So I'll take you through Instagram. I'll take you through something that is happening like always. So I'll be sharing that with you. But before that, so computer vision is basically a subfield of artificial intelligence that focuses on enabling machines to understand and interpret visual data, what we are seeing. Now we have eyes, right? The robots don't have eyes. So they use camera for the same. Now, how do you interpret those camera images? Moreover, if you use just normal camera or stereo camera, you're just, in case of stereo camera, you can estimate the depth, but you're just using a monocular camera. What will happen? You'll just be able to say that, yeah, this is the 2D image of the scene, but you never know that what is the depth of the image. The ones that are captured by a digital camera, like our phones, right? But when you move to this computer vision, the robots also need to know at what distance the things are happening. Like, it cannot just have that there is another table over there, but at what distance it is, that is also one of the primary concerns the robot should have, right? So computer vision is basically a subfield of artificial intelligence, I would say. And yeah, the machines need to understand and visualize the data, especially vision, much like human vision. So when we look at an image, what happens? We constantly recognize people, objects, and action. Now, computer vision essentially tries to give that ability to robots and machines. So in robotics, this means that the robot can use its camera to detect a red ball, to say that it is a red ball, to recognize a human face, or let's say just to follow a path. You might have heard of the line follower robot. So the goal is essentially to extract high level understanding from raw pixel data, right? So I'll take you through one of these Instagram feeds, but I don't think I'll be able to record it. Just let me see if yeah. Okay. I hope my screen is visible. It should open. Okay. So I'll just change my recording screen. Should be edge. Okay. Okay. Now what you can really see here is this. Okay. So you can see this video. So what is happening here is, this is basically something that goes inside the hotels that is not accessible to common public. So it is some preparation of coffee cups and different things. So basically it is some Starbucks, so it does not look like that, but yeah, it is some sort of cafe shop. You can see that. Now what it is doing, all of the people are already identified. Okay, everyone in the industry. So all the customers who are here, they have been marked with for how many minutes or hours they have been staying here. Okay, and this the people who are here, they are associated with cups. So the basically the food prepare करने वाले लोग जो हैं, so the chefs, we can say in this case. So yeah, they are labeled with what is their name and what is the number of cups that they're preparing. Now you can see the video. So, and Elon Musk has dropped an exclamation mark over here. So you can see this lady is preparing 20 cups, whereas the other two are 10 cups, and one of them is like 3 cups only. So you can know that who is not working well, who is not working efficiently. So it can be one of the methods in which you can fire that, okay, who is slacking and who has made all of the things very well. So I think I can turn on the video.
On warehouses, similar technology is used to monitor employees. They even allow AI to generate termination notices for workers with low productivity. But it doesn't stop there. Before long, everything around us, from cars to ships to our daily lives, could fall under AI surveillance. Everything will be tracked, monitored, calculated, and analyzed. If you're wondering what AI is really capable of, well, this is your answer.
I'll just play this.
Hey guys, this is a bit scary. No wonder Elon Musk gave this video an exclamation mark. This is footage from a coffee shop using AI to monitor its employees. The blue text with white letters indicates each employee, and the number shows how many cups of coffee they've made. You can see that an employee named Anna is working diligently, making a total of 20 cups. Meanwhile, Olga is hiding in the corner, slacking off, and has only made 3 cups. All of this is tracked by the AI, which then reports the findings to the boss. In Amazon warehouses, similar technology is used to monitor employees. They even allow AI to generate termination.
I just wanted to say that this is what is going on. So I'll switch the recording again to yeah. Okay. So having seen this Instagram reel that I showed you, in which people were using these AI tools and computer vision tools to basically isolate people, that to segment people, that this person is this person is this, and then you want to say that how many cups they are preparing. It helps you in firing also. So these things are being achieved. I'll show you another thing. Okay, let's move to the, let me remove this. Okay, let's see this. This one is something which I saw at Ahmedabad airport. So they had this floor cleaning robot over there. So you can see. So if you can clear it, I'll just come back. So if I come back to this thing, what I can show you is, if you see here is a camera, which is a RealSense camera, Intel RealSense camera. The fact associated with this camera is that it measures the depth as well, not just RGB images, but the depth. So it essentially knows at what distance you are standing from this camera. So it has a couple of not many RealSense camera over here, which actually helps it in knowing that, yeah, someone is here and I should stop, I should take a turn, so all of that. So here also computer vision comes into play, which actually senses that, yeah, there is a person over here and I should not go and collide with that person. So yeah, that is why I wanted to show this video now. So what essentially we are talking about is, okay, so computer vision consists of all these things: image classification, object detection, image segmentation. So image classification is, you want to classify different images. You might have heard of convolutional neural networks for all of this. Then this object detection is something in which you are detecting the objects, like if it is a person, if it is a cat, what it is, and then maybe the color also. Image segmentation is you are segmenting the things from the surroundings, you're not considering it to be a single thing. Then there is 3D vision, there is facial recognition, there is also emotion detection, and there is edge detection, which essentially helps you in creating the boundaries between two different objects. And there is some pattern detection and object tracking. Tracking as in what is happening. If you have seen an object, then where does it go at the next instant? So all of these. Now, the components of a computer vision are these things only. That there is a lighting in which a scene is placed. Okay, so the camera should be able to detect all of these. Once it detects all of these, then it should be able to make some interpretations and send it to computer for interpreting the scene. Now this computer has everything that is required to interpret the scenes very well. Am I connected? Yeah, I am connected. Okay. So yeah, this camera basically takes everything into account, and then you can see, you can know what is there in the scene, and this is possible only with the help of computer vision. Now, why do robots actually need vision? So think of a vacuum cleaner. It uses some camera. I hope you're familiar with LiDAR. So it is something that sends the light rays, and when it comes back, it is able to know that it is at some distance from the object. So basically a distance estimation device or a sensor. So if there is a robot vacuum cleaner, it uses a camera or LiDAR to avoid obstacles, right? So in warehouses, robots use vision to locate packages and to navigate around the workers. So humans are already there, right? So vision is crucial for navigation, detection and manipulation of all the objects, and making some autonomous decisions and mapping the environment also. So in this case, you can see this environment is being mapped. The robot now knows that yes, there is a height difference in between all of these, and these are the stairs, that it takes a route that way. Whereas in the leftmost picture, you can see that there is an image. Then you do the edge detection, which is being done over here. And here there is an object detection where you know that, yeah, this is a person. It has identified it to be a person and not a cat, right? Then there is some obstacle avoidance. If there is an obstacle, the robot should know that, yeah, I don't have to move forward, should not collide with it. So without vision, a robot would be like a blindfolded person trying to navigate a new room. It can work, but it's highly limited. So basically we need it for autonomous decision making, environment mapping, object detection, manipulation, etc. So for all of these reasons, we need computer vision. Okay. Now, if you want to know what is the application of computer vision in robotics, so self-driving cars actually rely heavily on vision system to detect lanes, signs, and vehicles and pedestrians. So all of these things. So if there, just imagine if there is an autonomous car, you will have to know that if it is going to change the lanes, what is happening, if it is in the middle of the lane, or it is going to go in the fields by getting off road. So all of those things. Sorry, I have a feeling that I'm getting disconnected. I'll just check. Okay. So yeah, the okay. So for all these things, for autonomous driving also we require vision. Now, in Amazon warehouses, you might have seen this picture already. Robots use vision to find and carry goods, right? So again, the drone. So this image is from Uri, the surgical strike. So it is, if you remember from the movie, they had bird kind of drone that they were using for sneaking into the buildings of the terrorists, right? So this is one of those like animated picture of the drone. So these are used for surveillance, detection of some movement, following people or paths. Okay. Then you can see this healthcare. So in healthcare, robots equipped with cameras can assist patients recognize emotions, what is gone with the patients, and they can respond to the gesture of the patients. So each of these applications requires a different level of vision sophistication, right? I hope you understand by now how vision is important. For any operation that you want to do, you must have a sense. Not always LiDAR helps, not always the ultrasonic sensor helps, but yeah, vision becomes important at some point of time. Like if there is an environment where you have a person, and let's say you have some other what to say, let's say some other wooden box kept over there, you won't be able to identify what it is unless you have some thermal sensors. So vision becomes important. Okay, now let's come to this image basics. So what happens at the core, an image is just a grid of pixels. So each pixel has a value of color associated with it, red, blue and green. If it is a grayscale image, it just has one channel intensity. So it is either going to be white or black. So understanding this helps us manipulate images with code. For example, uh, to detect objects based on color, we need to know how to extract the RGB images, how to process them. It could be RGB, it could be HSV. HSV is hue, saturation and value. Yeah. And one more is CYMK thing. Yeah, cyan wala. So all of these are really ways of defining the basic colors. Yeah, and how do you extract and process them? So OpenCV is a common library used in robotics for doing this. Okay, this is how we do. So when we come to OpenCV basics, it is the most widely used library for image processing in robotics. With OpenCV, we can load the image, we can display them. Okay, like this one, cv2.imshow. Then we can convert them to grayscale or HSV and access any live demo stream. So commands like imread, read images from your disk basically. IMShow actually displays them. CV2 color converts them between color spaces. So, and yeah, video capture accesses your webcam. So this basic functionality is enough to begin detecting colors, tracking motion, or finding objects in an image. This is just enough, just these 4 commands. All right. Now, let's move to the this live camera access. So, live camera access is fundamental in real-time robotic systems. For example, if your robot is doing something, you cannot have some process already done and then you need something in real time, right? You need to process the things in real time because your robot is working in real time. So live camera access is fundamental in real-time robotic systems. Robots often have these onboard cameras that act as their eyes. Then the CV2 or video capture lets us access these cameras. Once we have the video feed, we can process each frame like an image. So video is not being processed as video, it is rather processed as an image, okay, at some particular frequency. So we can apply color filters, we can detect objects, and we can track motion. So this really opens the door to real-time perception and interaction, right? As we saw in the airport case, the floor cleaning robot case, okay? Now, after this, so color detection is a great way to start with computer vision. So if you're going to do so now, computer vision, do start with color detection. So let's say we want the robot to track a red ball or red apple. So we will convert the image to HSV color space and apply a range of masked to highlighted red pixels. So the result would be a binary mask basically that we use to extract the red regions in the image. Wherever there is red, it would say that yeah, it is 1, it is whole black, and the other places it is whole 0. Okay, so this concept is used in sorting systems, pick and place robots, and even mobile robots that follow color coded paths. So it is helpful in object tracking and sorting and demonstration with real-time webcam. All right, now object detection can be done using simple thresholding or more advanced methods. So basic methods include color filtering and contour detection. Using CV2 dot, find contours is one of the commands. So advanced approaches involve this YOLO system. You only like look once. SSD, which is a single shot detector, or RCNNs, one of them is them. So these methods actually allow us to recognize multiple object classes with bounding boxes. And you can also have a probability that if it is a white object, it is detected with a certain probability. So making them suitable for tasks like autonomous driving or this robotic manipulation. So you can do color thresholding, that my blue lies from this region to this region in HSV range. So you are supposed to detect that. Okay, and the shape also, if you want to just have a rectangular bounding box, you can just have them. And then there are deep learning methods, which essentially most of the time it starts with CNN is not the complete story there. Actually, it's like the initial part of the, if you know neural networks, the initial part of the neural network comprises of CNN, and then you have multi-layer perceptrons only. Okay. I hope there is no problem till now. If it is not, then let's move to the next slide. Okay, then let's go to motion detection. So motion detection involves identifying changes in a scene over the time. So we can what we can do is, let's say if a person is walking from point A to point B. So at point A you have an image, at point B, at point intermediate 5-6 points you have an image, and then at point B also you have an image. So we can actually subtract the consecutive frames and look for differences. So this is useful in security robots or some interactive robots and human detection system basically. So more advanced system use background subtraction algorithms or optical flow to track motion vectors. So what I just wanted to tell here is about the optical flow, where given a scenario from the video, you can find, okay, what is my velocity? What is the speed with which the person is moving? What distance it has covered in what amount of time, and all sort of things. You can just find it out from the image from the video. So this is where optical flow comes into pictures, where it literally uses the video as a sequence of images, and then it tries to find out where the things are moving or how is the motion going. That is a part of optical flow. Okay, I hope this is clear. Then there is this line following robot. I think everyone does when they start robotics. So this is one of the earliest robot projects that I have been seeing. So students try this always. So using a camera, here more than a camera, it appears to be an ultrasonic sensor, but I assume it to be a camera. Okay, so using a camera, the robot detects a black or white line on the floor. By analyzing the position of the line in the camera frame, okay, the robot adjusts its motion. So it tries to get the input in camera frame, and then it converts it into base frame. Okay, all of those conversions actually happen with the help of rotation matrices. So this is an example of visual servoing, like using visual feedback for control. So this is used in warehouse robots and delivery robots. Okay. Okay, I hope it is clear. Now, yeah, this is face detection with OpenCV. So this uses hair cascades classifier. So it is basically a data set that helps you in face detection. It is available online and you can always download it and use it. So there is CV2 cascade classifier usage. So what really happens is, face detection is really important in human robot interaction. So using hair cascades and OpenCV, we can detect faces in real time. So the robot can use this to recognize the users, track attention, if you're paying attention or not, like if you're looking to some other side, then you're not paying attention, or if you are looking to the ceiling, you're not paying attention, all those things. Or it can be used to greet people. So this is the first step towards emotion and gesture recognition. Okay, which requires more advanced models but it starts with a face localization. So it is used for real-time interaction, for a human-robot interaction. And yeah, you can see this is expression and gesture recognition, and this is emotion recognition, where it is being recognized that a person is sad. So I don't know, recently I was seeing a video which actually had a person who was driving an autonomous car, and I think it had a voice, probably Alexa. I don't know, whatever was the bot for driving the system. It was trying to judge that, yeah, the person is frustrated, and then you need to listen to a very good music, although the person wanted to reach the office fast. So that are some of the hiccups that keep on happening. But yeah, this is how the things go. Okay, let's move to the next slide. This is visual servoing. Just a second. Yeah, this is visual servoing. So visual servoing actually refers to controlling the movement of a robot using vision feedback. Suppose a robot arm must align with an object. So instead of manually specifying the positions, the camera tracks the object and the robot adjusts its movement accordingly. So this creates basically a feedback loop, the correction loop. So this technique is basically used in robotic surgery, manipulation tasks, or some autonomous drones. It uses closed loop control using vision, where you have to correct always, and it aligns robots to objects or features. Okay. Now, this is the depth perception. So, robots don't just need to see, they also need to perceive depth. Stereo vision uses two cameras. If you know stereo vision, there are two cameras, and then with the help of two cameras, you map to a single point, and then you try to estimate the depth using disparity in the images. Okay, so stereo vision uses two cameras to estimate this distances. So there are few depth sensors or depth cameras like RealSense or Kinect. So what they actually do is they provide per pixel depth information. So this allows robots to like avoid obstacles or grasp some 3D objects or build maps of their surroundings. So it is a step beyond 2D image processing into a 3D world understanding. So here you can see that this person is there. Both of them are standing at two different distances from the camera. One of them is at 2.32 meters, other is at 1.38 meter. So we need to know, right, which is closer to the robot, which is farther to the robot, whom the robot is going to collide. It should not happen. So for those things, these RealSense cameras come into picture, where you have the complete sense of depth. So this point cloud or these colors basically tell you what is the distance. So it is used for 3D mapping and manipulation. Okay. Now, coming to ROS and computer vision. So sensor topics like camera, if I'm not sure if you've used ROS, but if you've used ROS, you would know that if you just interface a camera with ROS, if you node for camera inside the ROS workspace, then you have some topics being published like this. Though all of these topics are basically the inputs that are being drawn from the camera and will be used for further calculation, analysis, or anything. So this is used in integration with OpenCV and RealSense. So message types can be sensor messages, image, which has some particular features like pose, orientation, and all of those things. Okay, so yeah, ROS is often the middleware connecting all the components. So images are published over topics like this. And then with CV Bridge, we can convert ROS images to OpenCV format for processing. So ROS also supports launching camera nodes, publishing transformations, and using tools like RViz for visualization, right? So I hope this is clear. If it is, then let's move to the next. So yeah, I motivate you to go through the following things. So these are the basic mini project ideas. So to really understand CV in robotics, computer vision in robotics, you need to build something. You can just start with detecting the colors. Start with something very simple, okay? And then you build something. So here are some mini project ideas that I've put here. So one of them is you track the red ball using color detection. Then you have a face detection robot or a greeting bot. Then you have an obstacle avoider with some depth vision. And then you have color sorting arm with OpenCV. So these are all beginner friendly and give hands-on experience with real sensors and algorithms. So yeah, you can go with it. Here are some GitHub topics that you can go. So these GitHub topics basically contain all the links to what people are doing with vision currently. So many such projects are there. You can start with them if you're interested. I'm sure if you would be interested, if you've taken this advanced robotic course. That's why I'm telling you this. Now, the libraries and tools that we have here is primarily OpenCV, which is for image processing. Then there is NumPy for matrix operation. You might be aware of this. If it is a tensor, you have to go to Torch, PyTorch. Then there is Matplotlib for debugging and visualization. And then there is ROS2 for integration with actual robots. So these tools are widely supported and open source with great community resource. Please use them. Okay. So what happens? Computer vision transforms a robot from a blind machine to an intelligent agent. So we actually explored the basic image handling, object tracking and depth estimation. So with tools like OpenCV and ROS, you can implement these on real or simulated robots. So here are some great references. OpenCV.org, ROS ka hai, and then there is OpenCV, another GitHub. Then yeah, this book is really important, Algorithms and Applications by Richard Zelinsky. So this is one of the most important book that we use. And yeah, here is again a GitHub link which you can look to. So yeah, thank you for your attention. I hope this session gives you the confidence to start exploring computer vision in your robotic projects. So yeah, the floor is open for questions and feedback. Feel free to reach out in case you have any problem. But since I see that the audience is different who did not see the initial video that I had shown, I'll just go back to it because that was one of the interesting videos that gives you actually a motivation why you should, what is happening today. So I'll just, yeah, one of them is this video. So this was something on Ahmedabad airport in India where yeah, this is a floor cleaning robot and it has a couple of cameras placed over here. So if you see, there is a real sense camera here, there's a real sense camera here. Yeah, the cameras are all over. Oh, sorry. Yeah, the camera is here, the camera is here, and there were a couple of cameras, more than 10. So all of these are basically used for obstacle avoidance, detecting people and everything else. So by any person who comes before it, it won't just like collide with it. Apart from this, this was one of the very interesting videos that I saw on Instagram. Oh, it is already opened here. No, I'll just open it again. Before that, I'll also, okay, I'll do it later. It's not opening. Yeah. I'll try to turn on this sound also. I hope then. Okay. You can see this. So this is basically from a coffee shop where here there are people who are actually making the coffee and they are presenting to people. So you can see with every person there is some time associated, that for how much time they have been sitting here. And then here are the people who are actually making cups of coffee, and you have something who has made how many cups of coffee. And Elon Musk actually placed and commented an exclamation mark on this. You can see this video for yourself.
It's scary. No wonder Elon Musk gave this video an exclamation mark. This is footage from a coffee shop using AI to monitor its employees. The blue text with white letters indicates each employee, and the number shows how many cups of coffee they've made. You can see that an employee named Anna is working diligently, making a total of 20 cups. Meanwhile, Olga is hiding in the corner, slacking off, and has only made 3 cups. All of this is tracked by the AI, which then reports the findings to the boss. In Amazon warehouses, similar technology is used to monitor employees. They even allow AI to generate termination notices for workers with low productivity. But it doesn't stop there. Before long, everything around us, from cars to ships to our daily lives, could fall under AI surveillance. Everything will be tracked, monitored, calculated, and analyzed. If you're wondering what AI is really capable of, well, this is your answer.
Yeah, I hope you saw the video. Yeah. So, yeah, this marks the end of the, like, it was just a 1 hour session today because, yeah, just for your clarification. So, okay, I'll just change my screen to H. Yeah, there is something else that I wanted to show. Just a second. Yeah. So this uh, okay, I think it is visible. Okay, this is one of the good videos that I found.
Computer vision is seeing an increasing number of industry applications, monitoring and managing crop yield in agriculture, annotating and pinpointing anomalies in healthcare, facilitating warehouse logistics and manufacturing, and safety and navigation for autonomous vehicles. But what is computer vision, and why does it matter? Simply put, computer vision enables devices to use human-like vision capabilities. Broadly speaking, computer vision enables devices to perceive objects or patterns in images or video frames and uses that information for further analysis or decision-making using techniques like detection, classification, and segmentation. Computer vision can also help synthesize and generate new images and video, classify helmets for safety, segment parts of a road scene as drivable and non-drivable space, and even morph and adjust highly accurate, high-resolution images. Computer vision uses data trained on mathematical algorithms to analyze, interpret, and process images and video. Let's take classification for example. Computer vision enabled devices take images like this one of Fido and analyze the photo's pixels to extract features and characterize the image to see if there's a dog in the photo or not, and if it is actually Fido himself or not, based on images previously given. Computer vision software helps people solve the most difficult challenges and supports everyday tasks, including identifying where a farmer needs to water his crops and protect against weeds, pinpointing where firefighters deploy to extinguish a fire, and identifying bottlenecks and how to improve production and packaging on an assembly line. Computer vision software is the enabling technology to solve many industry challenges. Whether you are new to the field of computer vision or an expert developer, NVIDIA has the computer vision software for you to start from scratch, integrate and customize into your workflow, and scale for deployment. For more on computer vision software, check out NVIDIA's Computer Vision Solutions landing page in the link below.
So this is one of the useful videos. You can directly do this on NVIDIA's
what happens behind the
Isaac
scenes.
Sim or anything. So yeah, all of them is possible. Okay. So yeah, I think it is capturing. So just for your convenience, I just wanted to add this, that this is the, so you have this already available with you, I suppose. You get this in most of the announcements also, and moreover it is there as a part of the recordings tab also, a part just below the lecture section. So yeah, it has all the 12 weeks lecture. I'll be uploading this lecture as well. And then all of the slides are at this presentation folder link. So you can just go to it and you get the access to all the slides and all the codes that I have been teaching till today. And here you have all the YouTube videos. So in case you have missed any of them or you have come late or anything has happened, you can go through all of them. And yeah, if you have any questions, let me know. As it was a nice time taking this course, advanced robotics course. So I have so I am a PhD student, third year PhD student at IIT Gandhinagar, and yeah, I have learned robotics here, and after that, yeah, I have been TA for a couple of courses, but this was the first time I was taking a advanced robotics course. So yeah, it was a new experience for me, but I enjoyed it. I don't think you have MATLAB code in exam. You won't have MATLAB code in exam, I believe. You would have just the questions and answers from the lectures that you have been taught. So in the lecture that you were taught, all the 12 weeks, all the lectures that were there. So there was no MATLAB by professor, right? It was just a lecture. So conceptual questions and numericals will only be asked. MATLAB was something which I was teaching you for your benefit. Like it is not going to be a part of the exam. It is like to give you insight on how you can proceed forward, given the concepts, how you can apply them in MATLAB, how you can use them to solve daily robotics problems. So it was for all those reasons. And yeah, anytime you have, in any other case, if you have MATLAB, you are encouraged to write your own code. You should not follow anyone else's code, that the way it is done or the logic that is written. Try to come up with your own ideas, your logic, and that would be the best of all. So yeah, you have to always do it in your own way, not in someone else's way. Since I'm teaching you one way. There are infinite ways possible to do a task. Okay, is there any other question? So if you have missed, I think I took the 12th week lecture on Saturday. I'm sure you might have got the announcement, but maybe you might have missed it. So not many of you were present there on Saturday. So it was a 2 hours lecture covering the week 12 session, week 12 exercise session. So yeah, go through the lecture at the spreadsheet link that I shared with you, or that I showed you right now, this one. Not this one, sorry, this one. It has the lecture for that day also. So since many of you were not there, it was just recorded and you can access the recording and see all the problems that were discussed. It will help you in solving the assignment also. And yeah, today was the last session. It was just an hour session where I wanted to cover something new and solve all the doubts. If you have any doubts, you can tell me. Else I wanted to take it as a computer vision lecture to encourage you to do computer vision stuff, since you plan to be roboticists, or you might be even, I don't know at all. But yeah, if that is the case, then I think you should go with computer vision. You should go with all the robotics concept being used here. You should learn some AI, you should learn some machine learning, and then you should try to integrate all of these things. So reinforcement learning, if you've heard of, is a new domain today, which is basically used for rewarding and then penalizing, and then like that you train a robot to do a particular task. So all of these things are currently in marking, and each of them is rising rapidly. So you need to catch up. You're not too late, but you need to catch up, else you'll be left a lot behind. So yeah, if you're planning to have a career in robotics, or you want to have, if you want to do something bigger in robotics, then yeah, get started with all of these things. Look into what is happening. Yeah. NVIDIA's, so if you have GPUs with you, NVIDIA's Isaac Lab, then Genesis, then Mujoko, all of them have a couple of environments available. You have to use them. You have to start learning to use them, and then everything will eventually be good. Okay. Is there any other question or something that you want to clarify? If not, then I'll be closing the discussion, and yeah, all the best for your exams. That is all I would say. Yeah. So yeah, give the exam patiently. Don't like give up in the middle or take a lot of stress and do everything. So give the exams. It will be good. And yeah, you if you've gone through the course properly, you've already learned a lot from this course. So can I know from both of you what are you actually doing currently? Like masters, BTech student, where?
Uh, am I audible?
Yeah.
Okay. I am a BTech student studying robotics and AI in CV Raman, Odisha.
In where?
CV Raman Global University, Odisha.
Can you write that? I'm not able to hear it clearly.
Okay.
I heard CV Raman probably. Okay, you're from Myanmar. Okay, okay, okay. CV Raman Global University, Orissa. Okay, nice. So we have a lot of audience from different places. It's like from all over India, but yeah, from Myanmar. Language would be English only, so you don't need to worry. Everything will be in English. Okay, then. It was nice conducting all the lectures. I too learned from you guys. Hope you had some fruitful learning. Don't leave this course just here after completing your certification. Do go further. That's my advice. Since you have built on all these things, proceed forward. Okay, then. Thank you.